My name is Sarah. I'm presenting on behalf of my group. Leighanne was supposed to be here and she presented the talk, but she couldn't be here. I have her notes. I can kind of read them, so we'll just see how this is going to go. Our project is called, you can't see it, Development of an Accelerometer-based Positional Classification System, or as I like to call it, humans learning the machine. Basically, what we're trying to do is show humans in the hospital in different positions. The recent studies support that wearable device measured activity in hospitalized patients predict their readmission risk, their length of stay, and then if they come back with disabilities or any sort of loss of function. So what we're really focused on doing is offering posture or position detection that play things like Fitbit and Apple Watch. They mostly focus on how much you're walking. Hospitalized patients can't do that. They're mostly laying down, possibly reclining, but reclining is better than laying down. So we're trying to use machine learning to develop techniques to classify laying, reclining, sitting, standing, and walking in hospitalized populations. We are using these little, commodity accelerometers from Ambient Labs. Are called MetaMotion Rs. They are really cheap, but they're research grade accelerometers that we can draw XYZ axes from and do our processing on. And the type of machine learning that we're using is the random forest classification. So what we did was we collected about 15 older adults and we ran them through our postures to do the training data, and we labeled that. And we're getting pretty good results. You can see this is a confusion matrix. The black just basically means that the algorithm agreed with the actual labeled truth. But you can see up in the corner, laying is kind of an indicator of problems to come. So what happened when we actually went to the hospital and put the sensors on actual hospital patients, we found out that our algorithm didn't really match, and we had to look again and see why it didn't actually work out. So unlike the training data that we did on the healthy adults, where we told them sit, stand, walk, our test data on the hospitalized patients in the real world, they're not actually they're laying down might look like somebody else is reclining. The things that we thought were reclining were actually they're laying. And so as you can see on the first matrix, the laying and the reclining were not very clear. And so what we tried to do is collapse the category. We thought, okay, laying and reclining, kind of the same. Let's see what happens when that happened, when we collapse that, and we were still not getting very good results at all. It was nearly 40% inaccurate, so we had to kind of reassess what we were doing. We talked to our data scientist, works remotely. She's from a different company. So we talked to her a lot about it, and we figured out that what we needed to do was test in a more granular angle. So we went back and we found basically relabeling people at exact angles. So 30 angle, 15, 30, 45, and 60. Basically, this is our responding to the fact that the real world did not match our expectations. Because Duke is so open with their machine learning and we're able to go to all these different conferences, we were very aware that we couldn't really tweak our classification to reflect more accurate results. So luckily, we were able to figure out that, what we really need to do is just adjust our expectations. So that's kind of where we are right now. We are working on trying to get more testing data. We're trying to label it better and then get more validation data in the real world to move on with our project, but eventually get this out there, get it so people can wear it, and get the information into the electronic health records so healthcare providers can see, during the last 8 hours, all you were doing was laying down. We need to get you up, we need to get you moving, and get you checked out of the hospital faster. So that's it.